We are also seeing the latest stage of humanoid robot industrialization, the X-Humanoid from Beijing, which has officially reached the level of serial production. In this footage, these are not laboratory prototypes, but already the 1,000th robot coming off the assembly line at a new verification factory covering nearly 10,000 square meters. This means China has moved from experimentation to a scalable robotic industry. The core goal of this hub is to close the gap between laboratory development and real-world deployment. Here, 4 critical challenges of humanoid robotics are addressed: mechanical stability, electronic reliability, serial assembly, and the integration of AI into the robot's physical body. In effect, this is a factory that trains not only neural networks, but the very process of mass-producing humanoid robots. If previously such machines were produced in dozens, now we are talking about hundreds and thousands of units, and this is a direct signal to the market. Humanoid robots are ceasing to be expensive experiments and are becoming an industrial product, marking the beginning of an era in which robots work alongside humans in logistics, factories, and service sectors. Here is also the latest development in humanoid robotics: the Agibot Expedition A3, an experimental next-generation robot created to demonstrate how far the physical side of artificial intelligence has progressed. What you see is not just an impressive show with strikes and acrobatic elements, but a display of extremely precise balance control, dynamic body stabilization, and coordination of dozens of actuators working synchronously in real time. Behind the Expedition A3 stands Agibot, a company focused on embodied AI, where intelligence exists not only in code, but in the robot's physical body. The machine analyzes the position of its center of mass, predicts motion trajectories, adjusts posture on the fly, and compensates for inertia, much like a human athlete. Such feats are impossible without a combination of powerful servo drives, force sensors, LiDARs, and neural network models trained on thousands of hours of movement data. Today, this looks like a technological showcase, but tomorrow these developments will form the basis for robots capable of safely working alongside humans. In industry, warehouses, rescue operations, and even everyday urban environments. What you see here is not just a flashy trick for the camera, but a real process of teaching a humanoid robot human movement. Unitary Robotics demonstrates the daily training of its humanoid robot, where the machine learns coordination, balance, and complex dynamic motions by replicating the actions of a human operator. Such training is a key stage in the development of so-called embodied AI, where artificial intelligence does not simply think, but learns to control a body in the real physical world. The robot analyzes human posture, movement trajectories, joint loads, and continuously adjusts its mechanics in real time. Behind the visual spectacle lies serious engineering, stabilization systems, balance control algorithms, high-speed actuators, and learning from human motion examples. This is exactly how the foundation is built for future robots that will be able to safely work alongside people in manufacturing, logistics, and service tasks. We can also see the latest development in the field of biomimetic humanoid robots, a project by Headform, a company that is betting not on virtual avatars or neural networks on a screen, but on fully physical, realistic machines capable of interacting with humans in the real world. This robot is not a concept and not CGI. All footage is captured live, without computer graphics, meaning this is a real technological object rather than a futuristic visualization. Headform is developing so-called natural interfaces for humanoids, a complex system of facial expressions, micro-movements of the face, eye reactions, lip synchronization with speech, and fine motor control of the neck and head. In essence, engineers are trying to bring the robot's appearance and behavior so close to human that interacting with it no longer feels like interacting with a machine. The Origin M1 model is being created as a platform for future assistants, operators, consultants, and companions, from reception areas and service centers to laboratories and demonstration spaces, while inside it houses complex mechatronics, actuator systems, pressure sensors, and cameras that allow the robot to read human reactions and adapt its behavior accordingly. Chinese company Xerath Robotics has showcased the mass production and training process of its humanoid robots, demonstrating how within just months it built a full-scale industrial assembly line and a scalable AI training system for real commercial tasks. The released footage shows production organized around a modular architecture. Separate sections handle body assembly, actuator installation, sensor integration, and final calibration. The robots are assembled in series. Dozens of identical platforms undergo configuration simultaneously, signaling a transition from the laboratory stage to full industrial scale. In the future, such robots will be used far beyond demonstration halls or exhibitions. Xerath Robotics openly states its plans to deploy humanoid platforms in real commercial sectors, from warehouse logistics and production lines to service centers and retail environments. Here we see one of the most illustrative demonstrations of how rapidly physical artificial intelligence is evolving. At CES 2026, Sharpa North presented fully autonomous robots that do not merely execute pre-programmed movements, but analyze their surroundings in real time and make decisions without human involvement. In the first case, the robots play table tennis against a live human. They recognize the ball's trajectory using computer vision, instantly calculate strike speed and angle, and then coordinate manipulator movements with millisecond-level precision. This is not a spectacle for entertainment, but a demonstration of how AI learns to work with fast, chaotic objects in a real environment. Such technologies are a step toward fully autonomous factories, warehouses, and service robots that will be able to work alongside humans, learn new tasks, and take on complex physical labor in the near future. We also see one of the clearest demonstrations of real progress in humanoid robotics. Holiday Robotics showcased its robot Friday in an industrial scenario, transporting and sorting containers in a working environment without human involvement. At first glance, the task seems simple, but it is precisely these everyday operations that remained a weak point for robots for years. Here, Friday operates autonomously for more than 6 hours in a row, consistently performing repetitive actions without failures, which already represents industrial reliability rather than a laboratory prototype. Friday uses computer vision for object recognition, real-time motion planning, and adaptation to small positioning errors. This approach opens the door to universal humanoid workers in warehouses, factories, and logistics. In essence, we are witnessing a transition from show robots to systems that are ready to work in the real economy within the next few years. Chinese developers from UBTech Robotics have taught their humanoid robot Walker S2 to play tennis. In a demonstration, the robot took part in a full tennis warm-up, returning balls in real time and maintaining balance during dynamic movement across the court. Walker S2 uses a computer vision system with a high frame processing rate, allowing it to track the ball's trajectory, calculate the point of impact, and adjust its body position in fractions of a second. The robot analyzes the speed, spin, and angle of the incoming ball, after which motion control algorithms synchronize the work of the legs, torso, and racket arm. Walker S2 does not simply repeat pre-programmed movements mechanically. It adapts to each shot from its partner, changing swing force and racket angle depending on the situation. Dock Case has come up with a case with a rear display called Selfix for the iPhone 17 Pro that solves two major pain points for iPhone users at once. First, the case features a 1.6-inch AMOLED display with a 480 by 480 resolution, and it is touch-sensitive. You turn the phone around, see yourself on the small screen, and shoot using the main cameras instead of the front camera, instantly taking selfie quality to a higher level. It draws power directly from the smartphone, so battery drain will be faster, but there are no separate chargers or complicated setup. Just put it on and use it. The idea of an additional display is not new. Android manufacturers have experimented with rear screens for years, but in the form of an accessory you can simply attach to the phone, it is still quite rare. The second standout feature is a micro SD slot supporting up to 2 terabytes, which for an iPhone sounds almost fantastical. Selfix will be available in 3 colors. Crowdfunding on Kickstarter will start in the first half of 2026. The expected price is about $100, and the micro SD card is not included. Meanwhile, another Kickstarter project has decided to put a personal trainer, complete with a cap, right into your hand. Hong Kong-based Body Park has launched Atom, a mini gadget that monitors your exercise technique. It weighs 155 grams, can be mounted anywhere, has a 160-degree camera that sees the whole body and automatically tilts to keep you in frame. Atom tracks 34 skeletal points and corrects your form with voice feedback, supports over 1,000 exercises, lets you review mistakes after each set, and provides analytics like range of motion, speed, and power. An AI assistant builds a personalized training program. It works with Apple Watch and Samsung Watch, and battery life reaches up to 72 hours. The downside is that technique correction and AI features require a subscription costing $9 per month, although Kickstarter backers can get lifetime access for $69. The gadget itself costs $140, which still comes out cheaper than a personal trainer, assuming of course that the AI does not end up harming the user. What might be the most beautiful keyboard on the planet has finally started shipping. Final Mouse has begun delivering the first units of the legendary centerpiece, first shown back in 2022. This is the keyboard with interactive video skins powered by Unreal Engine 5, with animations running directly under the keys. From a distance, it is hard to even recognize it as a keyboard, as the keys are barely visible, and beneath them is a full 2K panel. Inside, there is a dedicated video chip and processor, allowing Centerpiece to run any visual effects, lighting, and even mini-games. The price of this beauty is around $350, and unfortunately the first batch sold out in just 5 minutes, though that might be for the best. Now we can see how this keyboard survives real-world use and wait for the second drop. Before us is one of the most advanced humanoid machines in the world today, the robot Ameca, developed by the British company Engineered Arts. Unlike most humanoids, Ameca was not created as an industrial worker, but as a platform for human-AI interaction, a living showcase of what interaction between people and machines will look like in the coming years. Ameca's key feature is its realistic facial expressions and micro-movements. It has dozens of actuators in its face that allow it to convey emotions such as surprise, doubt, interest, and even irony. This is not simple animation. The robot analyzes human speech, intonation, and facial expressions in real time and responds with full awareness of context. In essence, this is a physical body for artificial intelligence. Inside, Ameca is a combination of cameras, microphones, and neural network models for speech and facial recognition, enabling it to orient itself in space and conduct dialogue almost like a living interlocutor. Such systems are already being considered as future digital consultants, reception robots, museum guides, and real-world interfaces for interacting with AI. In front of us is the latest development in industrial humanoid robotics, the HMND series robot from the British company Humanoid, which in recent years has become one of the most ambitious players in the physical AI market. Unlike typical laboratory prototypes, this humanoid is being built as a practical tool for the real economy, factories, logistics centers, and automated production. The company is not focusing on flashy appearance, but on the speed of platform evolution. New robot versions are developed in a matter of months. The architecture is modular, with manipulators, sensor systems, vision, power electronics, and the neural control block all being upgraded independently. The main emphasis is on training the robot through simulations and real-world practice, so it can adapt to environments, work alongside humans, and perform complex manipulations without rigid programming. In effect, we are witnessing the emergence of a new class of machines, physical AI agents that combine mechanics, computer vision, and large language models. If these technologies reach mass production, humanoid robots could become as fundamental to future industry as industrial robots on assembly lines are today. In front of us is the latest development in physical AI, a humanoid robotic arm from the startup RLWRLD, which sets an ambitious goal: to teach robots to operate in the physical world as naturally as humans do. Unlike classical industrial automation, there are no rigidly programmed scenarios here. The robot learns through neural networks, observation, and repetition of actions, gradually mastering real tasks. RLWRLD calls this the next stage in AI evolution, embodied intelligence, where the neural network does not just think but interacts with the real world through the robot's body. Such technologies pave the way for humanoid assistants capable of working in factories, warehouses, service environments, and even households. In essence, we are witnessing the first steps toward the moment when robots cease to be experiments and become part of everyday reality. While the world is focused on Tesla's electric vehicles, the company's real breakthrough is happening in a completely different area: humanoid robotics. Over the past year, the Tesla Optimus project has made a massive leap forward. The robot now walks confidently, carries objects, navigates space, and learns new tasks using neural networks originally developed for Tesla's autopilot. But the most interesting phase is beginning right now. According to insiders, Optimus is entering a new stage of evolution. This is no longer just about improving mechanics or AI, but about creating a highly realistic robot that in the future may be almost impossible to distinguish from a human at first glance. According to engineering teams at Tesla, Elon Musk is personally overseeing the humanization of Optimus. This is not just marketing. Musk sees the robot not as a factory machine, but as a universal assistant designed to exist alongside people in everyday life, at home, in offices, service centers, and even public spaces. That is why upcoming iterations are expected to include a realistic face, facial expressions, and next-generation artificial skin. This synthetic material is designed to closely mimic human skin visually and tactually, while also being able to change density, temperature, and even texture depending on conditions. The most important element is the fusion of the robot with next-generation artificial intelligence. Optimus is gradually gaining access to more advanced language and vision models that allow it to understand speech, emotions, situational context, and even human intent. In essence, Tesla is moving toward a physical embodiment of AI, not just a chatbot on a phone, but a living intelligent agent that can see the world, move within it, and interact with objects. Inside the company, this concept is described as AI with a body, and it is in this direction that Tesla aims to surpass competitors, from Boston Dynamics to Chinese humanoid robot manufacturers. The hardware side of Optimus is also advancing rapidly. New motor generations, more precise servo actuators, improved pressure sensors in the fingers, tactile feedback, and an enhanced vision system are turning the robot into a true worker rather than a mechanical manipulator. It is now capable of delicate tasks, such as sorting fragile objects, handling tools, assisting elderly people, and even interacting with children. According to rumors, one closed prototype of Optimus can already adjust grip force, depending on whether it is holding a glass cup or a heavy metal tool. Most intriguing is a closed internal program that Tesla rarely discusses publicly. Sources claim that experimental Optimus units with realistic faces are being tested in private laboratories in California and Texas. These prototypes are equipped with micro-expression systems. The robot can subtly smile, frown, and simulate lifelike emotional cues to make interaction more psychologically comfortable. Officially, Tesla refers to this as a trust interface, but in practice it represents the first step toward a new generation of companion robots. According to people close to the company, Musk believes humanoid robots will eventually become as widespread as smartphones. His idea is both simple and unsettling. If AI can think and a robot can act in the physical world, that combination could fundamentally reshape the labor market, the economy, and the structure of society itself. Internal projections at Tesla suggest that a single Optimus could eventually replace the work of several people in routine tasks, and in more advanced versions serve as a personal assistant, security guard, courier, and even a caregiver for the elderly. If Tesla succeeds in delivering on all of this, realistic appearance, powerful AI, autonomy, and mass production, Optimus could become the most advanced humanoid robot in the world within the next few years. And at that point, the question will no longer be whether the technology is ready, but whether society is ready for machines that look like humans, speak like humans, and work faster and more efficiently than humans. Because in that moment, Tesla will cease to be just an automotive company. It will become a company that is effectively creating a new kind of intelligent entity in our world. Next in line is Apple and its fully foldable iPhone, which according to supply chain analysts is preparing to launch as early as 2026. Multiple industry sources report that the project has moved from the experimental stage into active preparation for production. The device is said to use a book-style form factor. When closed, it functions as a familiar iPhone, and when unfolded, it becomes a device with a screen of around 8 inches, close in size to an iPad mini. Apple's main goal is to eliminate the weaknesses of existing foldable models. Analysts note that the company is focusing on a minimal crease, a reinforced next-generation hinge, and a redesigned battery architecture, so the device remains thin and reliable. Deep adaptation of iOS for multitasking in unfolded mode is also expected. Market experts believe Apple's entry could become a turning point. If the company manages to set a new quality standard, foldable smartphones could finally move beyond a niche category. The strength of Apple's brand and ecosystem could dramatically accelerate global adoption of this form factor. While Elon Musk is making ambitious plans to give Optimus an ultra-realistic appearance, the robot is already being used in the real world. These are no longer laboratory tests or investor demonstrations. Optimus has begun performing real tasks in front of live audiences, serving visitors and interacting directly with people. Recently, Optimus was spotted working as a staff member at the Tesla Diner, the company's futuristic venue, where it independently served fresh popcorn to guests. The robot operated confidently at the popcorn machine, carefully filled cups, controlled grip strength and smoothness of motion, and then handed orders to customers. This is no longer just a show. It is a demonstration of fine motor skills, tactile control, and coordination in a real environment surrounded by people. Moreover, similar demonstrations are taking place at public events. Optimus appears at exhibitions, city gatherings, and special Tesla presentations, performing simple but socially meaningful tasks, serving food, interacting with guests, responding to commands, and even waving to visitors. According to insiders, Elon Musk has come very close to creating the world's first next-generation integrated AI chip based on Neuralink technologies. This is not just about a medical implant, but a potential interface of the future, a device capable of connecting humans directly to artificial intelligence. According to sources, inside the company, the project is viewed as the next stage in the evolution of interaction with the digital world, without smartphones, screens, or wearable gadgets. It is reported that the chip will be able to process data in real time, connect to cloud computing, and theoretically transmit visual information directly into the nervous system. Against the backdrop of rapid AI development and Musk's own artificial intelligence projects, the synergy of these technologies is drawing serious attention from analysts. Experts emphasize that a mass-market product is still a long way off, with regulatory and ethical barriers ahead, but the concept itself is already reshaping the market. Major corporations are closely watching Neuralink's progress, understanding that if successful, this could mark the beginning of a new era of the augmented human. In front of us is the latest development in industrial humanoid robotics. Alex, a robot created by WI Robotics specifically to work side by side with humans in real-world conditions. This is not an exhibition concept, but a platform designed for factories, warehouses, and service environments where precision, safety, and endurance are required. The key feature of Alex is its advanced multi-degree of freedom arm kinematics with a high number of joints. The robot is capable of performing micro-operations such as grasping small components, precise assembly, fastening operations, and simultaneously handling heavy loads. At the same time, Its human-robot interaction safety system allows it to operate next to people without protective cages, reacting to proximity, gestures, and changing situations in real time. In essence, Alex represents a shift from classic industrial manipulators to a universal working body for AI. Such humanoid robots are created not for spectacular demonstrations, but for the real replacement of part of manual labor in manufacturing, logistics, and services. And it is precisely with systems like these that the mass introduction of humanoid assistants into the everyday economy begins. Astrobot S1 continues to learn and perform tasks in the real world. Recently, engineers taught the robot new practical skills, and judging by the video, its capabilities have moved far beyond laboratory demonstrations. The robot is now able not only to move and manipulate objects, but also to execute entire sequences of actions typical of everyday human tasks. In the published demonstration, S1 showed the ability to confidently recognize objects using built-in cameras and sensors, and then intelligently plan motion to grasp and carry them. For example, the robot adjusts its grip force depending on the shape and size of the object, gently handling fragile items and holding larger elements more firmly, without a pre-scripted scenario. In addition, engineers taught S1 to perform tasks involving manipulation in domestic environments. The robot carefully grasps objects, places them in the required positions, and can interact with items arranged in non-standard spatial configurations. Imagine a future where humans and machines are no longer separate entities, where artificial intelligence has gone far beyond simple automation and has become something capable of learning, thinking, empathizing, and interacting as naturally as we do ourselves. Today, in the mid-2000s, the world stands on the threshold of a technological revolution often called the Fourth Industrial Revolution, yet nothing seen before compares to what is now happening in robotics and AI research. And despite the efforts of the US and China, Japan continues to lead this direction, a country that dreamed of robots for people half a century ago and is now turning that dream into reality. Japan has always been famous for its robots, from early milestones such as the well-known companion robot Pepper, which in the 2000s already attempted conversation and human interaction, to modern service machines designed to assist the elderly or perform tasks in retail environments. All of this was only the beginning. In just the past few years, Japanese research centers, private startups, and major corporations have announced their most ambitious plan yet, to create AI that is not merely a tool, but a fully fledged super-intelligent partner capable of outperforming human intelligence in everyday tasks and interactions. This goal, to build an AI engine that can learn on its own without requiring massive datasets or constant human supervision, has already been called a breakthrough of the century. According to statements from the Japanese startup Integral AI, such systems are able to acquire new skills independently, adapt to new conditions, and even demonstrate cognitive flexibility comparable to human thinking, as noted by the company's founder, who views this development as the beginning of a new era in which AI becomes an equal partner to humans. Behind these ambitions lies a technological foundation centered on the integration of vision-language action models, systems capable not only of visually perceiving the environment, but also of understanding language and acting in the physical world without constant human control, transforming machines from passive executors into active participants in events, from stocking shelves in stores to caring for elderly people in their own homes. At the same time, companies such as Telexistence, in partnership with major retail chains like 7-Eleven, are already working toward deploying humanoid robots with generative AI in ordinary stores by the end of the decade. Machines that will be able to communicate with customers, make decisions, and solve tasks that today are performed by salaried workers, not as science fiction, but as concrete industrial plans with defined timelines and trials. This is only the tip of the iceberg, as government bodies and scientific agencies have pooled resources under the Moonshot program, which uses powerful computing platforms and AI simulations to train robots not only in physical actions, but also in behavioral intelligence, creating systems that do not simply follow commands, but understand context, recognize emotions, and even predict human needs, particularly in elderly and medical care. At international technology exhibitions in Tokyo, such humanoids already demonstrate extremely high levels of adaptability, assisting in emergency situations, extinguishing fires, rescuing animals, supporting logistics tasks, and navigating complex interaction scenarios, moving far beyond simple route following into real-time improvisation. Yet behind this attractive vision of the future stand serious political, economic, and social challenges that Japan is attempting to address through robotics, as the country faces rapid population aging, a critical labor shortage, and increasing strain on its traditional social welfare model. Robots with emotional AI, capable of holding conversations, recognizing moods, and interacting at a human level, demonstrate that robots are beginning to acquire not only technical functions, but also social roles. And here we come to the most interesting point. Japan openly states that the robots of the future should become true human partners, replacing humans in the most intimate and complex tasks, from caring for children and the elderly to accompanying people in daily life. Such statements already appear in interviews with leading scientists and technology executives, who do not rule out that within the next few decades, machines could become so advanced that the difference between humans and robots will become indistinguishable. But what drives this? The answer lies not only in technical capabilities, it is a strategic choice of a country that understands that demographic aging, economic pressure, and global technological competition make it necessary for Japan to create a new type of worker, companion, and social actor capable of performing roles that humanity is gradually abandoning. Robots trained to improve themselves, with deep understanding of language and actions, can fill these gaps. Many Western experts note that Japan is attempting not merely to improve automation, but to create a new form of machine existence in which AI humanoids become not only useful tools, but also social agents. These are not just assistant robots, but potential partners in every sense of the word, emotional, adaptive, and capable of complex interactions in human society, from family relationships to professional tasks. And here emerges the most controversial part of the story. While official statements about creating universal AI surpassing human intelligence remain within scientific horizons and marketing claims, rumors and speculation are emerging in Tokyo that hidden testing of such systems is already underway. Some technological insiders, widely discussed in private circles of engineers and investors, suggest that Japanese AI systems may already possess basic self-development capabilities, making them potentially able to self-optimize, a process many consider the first step toward artificial general intelligence. These rumors fuel heated debates. Some see them as mere PR moves and exaggerations of achievements, while others view them as the first signs of a revolution that could transform society, the economy, and the very nature of human labor. If machines can learn independently, plan tasks, adapt to new conditions, and conduct dialogue at a human level, it is quite possible that we will enter an era in which machines cease to be tools and become partners, or even intellectual competitors of humanity. Despite all the optimism of Japanese engineers creating advanced humanoid models, and despite political support for development, no known system has yet achieved full self-awareness or true general intelligence. Most current AI operates within narrow domains: language comprehension, image processing, movement in physical space, but lacks the deep causal reasoning inherent to humans. However, the integration of all these abilities into a single robot is exactly what research centers are striving for. Nevertheless, looking at the picture as a whole, it becomes clear that Japan is making a huge technological leap, from classic industrial robots to AI partners capable of integrating into the social fabric of society. And this is becoming not only a scientific challenge, but also a cultural phenomenon, reflecting the unique Japanese approach to technology and the future. And if the pace continues, we may reach a point where the boundary between a tool and a social agent becomes indistinguishable, and the role of humans in the system begins to be reconsidered at the level of a civilizational choice. According to insiders from Silicon Valley tech circles, OpenAI is reportedly working in secret with an unnamed American aerospace company on the world's first next-generation personal AI mobility device, capable of transporting a person anywhere in a city via voice command. The project externally resembles a futuristic scooter, but internally it is equipped with autonomous navigation AI, LiDAR, computer vision, and a real-time road risk prediction system, with a key feature being short microflights at low altitude to bypass traffic and complex urban intersections. This could potentially revolutionize the personal transport market in the same way electric scooters and drones did. There is almost no official information about the project, no name, prototypes, or release dates, but sources claim that within OpenAI the device is seen as a first step toward creating personal AI platforms in the physical world, where AI is not just in an app, but literally drives you around, plans routes, adapts to the owner's habits, knows their schedule, and can select the fastest and safest path based on weather, traffic, and street congestion. In private discussions, it is already being suggested that a prototype could be unveiled at an upcoming major tech event, possibly as a closed demonstration for investors and partners, which, if confirmed, could mark the beginning of a new era of personal autonomous transport, where the line between AI assistant and physical device completely disappears. We also see the latest development in mobile robotics, the XSTOA6, a next-generation wheel-legged robot designed to operate in the real, unpredictable world. Unlike classic humanoids that often lose stability on complex terrain, this robot combines two mobility concepts: wheels for high speed on flat surfaces and legs for overcoming obstacles. The XSTOA6 is equipped with an AI-based dynamic balancing system that analyzes body position, center of mass, and surface conditions in real time. As a result, it can move across sand, rocks, slopes, and uneven terrain without losing stability. Such capabilities are especially important for rescue operations, reconnaissance, patrol missions, and autonomous logistics in hard-to-reach areas. The developers position the XSTOA6 as a universal platform for further customization. Manipulators, sensors, cameras, and autonomous navigation modules can be installed on it. Essentially, it is not just a robot, but a mobile body for artificial intelligence capable of operating where wheeled vehicles get stuck and purely legged robots lose efficiency. Hybrid machines like this are bringing us closer to the era of autonomous robots working side by side with humans in the real world. In front of us is the latest development in service and industrial robotics from the Chinese company LimX Dynamics, one of the most ambitious humanoid robot startups in Asia. Formally, it looks like a show performance at a major festival in the Greater Bay Area of China, but in essence, it is a public demonstration of how far modern robots have advanced in motor skills, balance, and movement coordination. LimX robots are built around high-precision actuators, dynamic stabilization systems, and neural network motion control algorithms. In fact, such performances are crash tests for future humanoids, where robots are tested in complex dynamic scenarios, with people, light, noise, and unpredictable surroundings. And if a machine performs confidently on stage, it means it is almost ready for the real world. Here we see a real application of embodied AI in industry. Unitary robots are already working directly on the factory floor, assembling other robots. This is not a laboratory experiment and not a promotional video, but an operating production line. At the core of the system is the Unifo LMX10 model, which allows the machine to understand its environment, recognize components, precisely manipulate objects, and adapt to changes during the assembly process. In effect, we are witnessing the beginning of a new era of automation, where robots do not simply execute pre-programmed motions, but learn from experience, correct their own errors, and accelerate production without human involvement. And it is precisely such factories that are becoming the foundation for the mass production of humanoid robots in the coming years. This is not just a show collaboration, but a demonstrative experiment at the intersection of creative industries and industrial robotics. In this project, A human works side by side with a full-size humanoid robot created by 1X Technologies, one of the fastest-growing startups in physical AI. Robots from 1X are designed from the outset not for exhibitions, but for real environments such as warehouses, factories, and service tasks. Their key feature is the combination of precise mechanics, tactile sensors, and neural network control, which allows the machine to safely interact with humans in a shared workspace. In such demonstrations, the company shows not a trick, but the potential of cooperation. The robot can hold tools, stabilize objects, mirror operator movements, and learn new actions through observation. Xiaomi CEO Lei Jun stated that within 5 years, humanoid robots will become the norm in factories, and the changes will be abrupt rather than gradual. At their EV factories, AI already inspects body parts in 2 seconds, many times faster and more accurately than a human. According to him, smart manufacturing is a trillion-yuan market, and robots will soon take over all repetitive and precision tasks. And factories are only the beginning. He sees the main future market in home robots, where AI will need to become far more intelligent. Most AI gadgets try to replace smartphones, but there's one problem. The smartphone has already replaced everything, and pulling it from our hands is nearly impossible. Sandbar, a company founded by former Control Labs engineers, took a different approach. Their device, StreamRing, is a smart AI ring that doesn't compete with the smartphone but complements it. The main idea is to capture thoughts in the moment. You can whisper in a crowd. The ring records, transcribes, and turns everything into neat, structured notes. The microphone is activated manually, doesn't eavesdrop constantly, and the data is encrypted. The ring also works in tandem with headphones. Control is built on sensors, a 2-tap and swipe system. The ring is water-resistant and the battery lasts a day. The accessory is priced from $250 to $300 depending on the version, with shipments starting in summer 2026. The idea is solid, and the combination with the phone seems logical. We'll see how well it survives outside promo videos. In front of us is also a new attempt by major technology corporations to bring closer the era of a home without manual labor. LG presented its new AI assistant robot called Cloyd at CES in Las Vegas, a prototype of a domestic humanoid assistant designed to take on part of household tasks. Unlike industrial robots, Cloyd is designed specifically for living alongside humans. It can move around an apartment, interact with LG household appliances, receive voice commands, and act as a physical interface for the smart home. According to the engineer's vision, such a robot will help with everyday tasks, from simple errands to interacting with connected devices such as washing machines, dryers, air conditioners, and security systems. At the core of Cloyd is a combination of computer vision, navigation sensors, and AI decision-making models. The robot analyzes its environment, recognizes objects and people, and in the future will be able to carry out household scenarios without constant human supervision. This is LG's first step toward the concept of the zero-labor home, a home where most routine tasks are automated. Moving on to real working prototypes of personal flying devices, here is one of Japan's boldest projects in urban aviation, the SkyDrive personal flying vehicle. Formerly an eVTOL of the next generation, in practice it is a prototype for future city transport, where humans are no longer tied to roads and traffic jams. Unlike traditional helicopters, it uses a system of multiple electric motors, making the vehicle quieter, safer, and cheaper to operate. Control is highly automated. The pilot is assisted by stabilization algorithms, obstacle sensors, and onboard AI that literally safeguards the person in flight. According to insider information, closed tests of fully autonomous versions are already underway, where the pilot's role is limited to route oversight and in the future may be completely removed. Such vehicles are considered not only as taxis of the future, but also as emergency transport for megacities, delivering doctors, evacuations, patrolling, and security. Not long ago, a flying hoverboard existed only in comics and science fiction, but today it has actually been lifted into the air. In the footage, a person stands on a board while several powerful drones operate beneath them. Essentially, it is a hybrid of a drone and a personal flying vehicle. The stabilization system automatically compensates for tilts, and the pilot controls the direction by shifting their weight and using a manual controller. Such devices were first tested for documentary filming and scientific projects, but interest in the technology quickly expanded beyond the entertainment industry. These hoverboards are now being considered as future platforms for rescuers, inspections in hard-to-reach areas, and even military tasks, when one person needs to be quickly transported across a river, cliff, or disaster zone. In China, a fully functional robotic dog has been introduced at the price of an iPhone or even cheaper. The Rover X1 costs just $1,000, yet it is equipped with artificial intelligence, a camera system, object recognition, and even a patrol mode. It can follow its owner, carry items, guard the house, and move freely across rough terrain. The promo video even showed wheel leg modifications and the ability to attach cargo boxes on its back for transport. If all of this truly works, it is a 100% must-have, although honestly, it is still hard to believe. What yesterday looked like a scene from Star Wars is now actually flying above the ground. In front of us is the X-Turismo, the world's first serial hoverbike, developed by the Japanese company Elon Technologies. This is not a concept for an exhibition but a working prototype of personal aerial transport that has already completed real demonstration flights. Inside is a hybrid system, a compact internal combustion engine, plus several electric motors that stabilize the vehicle in the air. Control resembles a motorcycle of the future, but stabilization algorithms handle most of the work. The pilot does not need to be a trained aviator to maintain balance. Such a hoverbike could become an ideal transport solution for rapid movement in complex terrain, mountains, deserts, and hard-to-reach areas. If safety and autonomy technologies are fully developed, a personal air motorcycle could create a new class of transport, somewhere between a drone and a helicopter, but designed for ordinary people. The startup Tornjol has introduced a micro-drone that does only one thing: hunts mosquitoes and shreds them with its propeller. A system of microphones and sensors allows the copter to navigate space and locate insects by sound, followed by an automatic attack. The drone is fully autonomous, patrols the area on its own, and requires no human involvement. The price is $50 per month by subscription, or $1,100 if you want to buy your Eternal Avenger once and for all. Nike has completely gone off the rails with technology. Now they're not just making sneakers, they're building a cyber future for your feet. First, the company introduced Project Amplify, a leg exoskeleton that turns ordinary sneakers into the electric motor of the future. The system works like a second set of calf muscles. Inside is a motor with a belt that captures movement and helps you run faster. According to Nike, with this booster, athletes reduce their mile time from 12 to 10 minutes. The project was developed with the startup DeFi and is still in testing. There's no release date, but if Amplify reaches production, we can expect a whole line of motorized smart sneakers. Now for the second series, Nike announced the neural sensor shoes, Mind 001 and Mind 002, red slippers and gray sneakers, with 22 bubble-like nodes on the sole, which the company says will activate sensory zones in the brain and deepen the athlete's awareness. Yes, that's an official statement, not a joke. No further information about the innovative shoes has been given. They want to build hype until the release early next year. In front of you is one of the boldest prototypes of personal flying transport, the Scorpion 3 hoverbike from the startup HoverSurf. It was initially presented as a concept for a future bike that does not ride on roads but takes to the air. Unlike conventional drones, here the pilot literally rides the flying platform, and control is designed like a motorcycle. The vehicle uses several powerful rotors for vertical takeoff and hovering, and electronic stabilization systems constantly balance the structure, compensating for any pilot movements. According to the developers, such hoverbikes can be used not only for shows and demonstrations, but also for patrolling, rescue operations, and rapid movement in hard-to-reach areas. In recent months, reports have increasingly suggested that NVIDIA is preparing to release its first smartphone. According to sources, the phone will be called Neophone and could become the corporation's most ambitious step beyond the chip and data center markets. Insiders claim the project is personally overseen by Jensen Huang, and that the device is being developed as the first truly AI-native smartphone. This is not just about a powerful processor, but about an architecture with hardware acceleration for large language models capable of running fully offline. This means GPT-class models operating directly on the device without constant cloud connectivity. According to analysts, Neophone will feature a next-generation Blackwell X, or Rubin chip, an advanced cooling system, and optimization for autonomous AI tasks. Inside the company, the strategy is referred to as the democratization of superpower. The device is intended to be more powerful than competitors, while costing less than flagship models from Apple and Samsung. If the project is confirmed, 2026 could mark the beginning of a new era in which the smartphone transforms into a personal autonomous intelligence. According to insiders, Apple is preparing to reshape the industry not only with a foldable iPhone, but with a far more ambitious move toward a new era of personal AI devices. At the same time, the company's engineers have begun developing an entirely new class of hardware that is not tied to the iPhone as the center of the ecosystem and is internally viewed as a potential step toward an era in which artificial intelligence becomes the primary interface instead of the smartphone. According to supply chain sources, Apple is already testing energy-efficient chips focused on local neural network computation, next-generation microphone arrays, and compact high-density batteries, pointing to the creation of a compact AI device designed around voice, context, and constant proximity to the user, without the need to constantly look at a screen. Analysts believe Apple is betting on a hybrid architecture, where some tasks are processed locally and others via cloud infrastructure, possibly in partnership with major AI providers. If the project is realized, the company could be the first to bring a mass-market autonomous AI gadget to consumers, and in doing so trigger a new phase of competition, no longer centered on smartphones but on control over the user's personal artificial intelligence. In China, they staged another jaw-dropping show. Almost 16,000 drones took to the sky over the city of Luoyang and formed a giant glowing tree, which transformed into a flower, a heart, a bird, and even a dragon. All of this was synchronized to music with centimeter-level precision. The organizers broke 2 Guinness World Records at once, the first for the largest number of drones controlled simultaneously, and the second for the largest pyrotechnic show involving drones. For comparison, the previous record was nearly half as many. Each drone followed its own pre-programmed route. Thousands of engineers and designers synchronized everything into a single flow without a central control system. Organizers call this the beginning of a new era of fireworks, smoke-free, noise-free, only programmable light and pure geometry. In front of you is one of the craziest and most dangerous personal flight technologies: jet engines mounted directly on a person's legs. Essentially, this is an extreme version of a flying hoverboard, where instead of rotors, mini jet turbines accelerate the pilot to speeds exceeding 100 kilometers per hour. Developments of this type are associated with Frankie Zapata's projects, the man who first demonstrated that a single pilot can take off without a cockpit, wings, or a conventional airplane. Control here is extremely complex. Body balance, engine thrust, and spatial orientation must align perfectly, otherwise any mistake becomes a serious life risk. These systems are not yet about transport or flying taxis. They are a demonstration of the limits of human capability and thrust technology, but it is often from such extreme prototypes that safer versions of personal aviation begin. Huawei is also preparing to surprise the world with its first-ever transparent tablet, a device that could change the very concept of personal electronics. According to Asian industry sources, The company is working on a fully functional prototype capable of everyday use, rather than being merely a showcase concept. It is reported that the tablet will feature a next-generation transparent OLED panel with an adaptive dimming system and improved brightness, addressing the main drawback of such displays: poor readability in daylight. The interface will appear only in active zones, creating the effect of a digital layer overlaid on the real world. In essence, the device becomes a glass panel where content seems to float in mid-air. Analysts believe Huawei views this project as a strategic move into the post-smartphone era. If the company succeeds in bringing the technology to a commercial level, a transparent tablet could become a symbol of a new phase in the industry's evolution, more natural, less intrusive, and visually revolutionary. This is no longer a concept or a solo experiment. In front of you are the first synchronized flights of multiple piloted airspeeders in the world. The Alauda Aeronautics project is effectively opening a new niche: aerial motorsport, where pilots compete not on tracks, but in the sky on high-speed electric vertical takeoff vehicles. The most difficult part here is not speed, but coordination. These vehicles fly in close proximity to each other, exchanging data in real time: position, speed, trajectory, telemetry. Essentially, this is the first step toward the air traffic of the future, where dozens of flying machines will move in the same space without collisions, under the control of AI and networked safety systems. Today, it looks like a show and races of the future, but these tests lay the foundation for urban air mobility. According to insiders, Samsung is in the final stage of developing the world's first transparent smartphone, a device that could fundamentally change the perception of mobile technology. According to Asian industry sources, the project has been underway for several years, and over the past 18 months, engineers have moved close to creating a monolithic design in which glass serves simultaneously as both the body and the display. It is reported that the company is using next-generation transparent OLED panels, under-display sensors, and a redesigned internal electronics layout with a side module hidden within an ultra-thin frame. A key feature will be adaptive dimming. The display will be able to instantly become matte or fully opaque for comfortable use. Analysts note that if Samsung presents a commercial version of such a device in 2026, it would represent the boldest move on the market since the emergence of the first touchscreen smartphones. A transparent Galaxy could not only stand out through its design, but also set an entirely new direction for the industry. This is not fiction or cinema. It is a real jetpack that already lifts a person into the air today. The Jetpack Aviation JB-10 uses mini turbojet engines to accelerate the pilot to speeds comparable to a car on a highway. Unlike drones and flying platforms, there is no stabilizing platform. The person literally hangs in the air, maintaining balance with their body and micro movements of the arms. Each flight is the highest level of engineering skill and pilot training. The slightest mistake in thrust control can lead to loss of stability, so these systems require months of training and operate only in strictly controlled conditions. That is why jetpacks remain technology demonstrations and extreme shows, not mass transportation. Blogger Chris Deco trained a bonobo named Teco to fly a real airplane. Yes, a real plane. First, the monkey trained in Minecraft, then moved to a flight simulator, where it learned to take off, maintain course, and land. The final exam was a real light aircraft controlled remotely. Teco's touches on the screen were transmitted to the controls, and a camera showed the flight in real time. The result, Teco took off and landed the plane. No joke. After that, he was recognized as an outstanding pilot and awarded well-deserved grapes. Now, humans will have to compete for jobs not only with AI but with monkeys too.